Hello everyone. I hope I'm audible. Can someone please confirm if I'm audible or not? Hello. Am I audible? Can someone please confirm if I am? Okay. So let's look at week two lectures. And first, I will try to do because we have not looked at the binary card tricks and lim things from week one. So first, we will revisit those things, and then we will do some recap week two lectures, and I will ask some of the questions to you from week one and week two. So I hope you have studied week one lectures at least. Let me share my screen. So, okay, I hope this is visible. Um, Similar to the last time, please scan this QR and join in this Minty quiz. So anyone who has any comments can write it in the chat, uh, in Zoom chat or in the anonymous chat in the menti.com, which will be given in the end that you can write your comment to you questions so I can get your questions. So I for today's lecture, I will just provide you some recap that what is binary card trick and how it happens and how do you implement it. And I will ask some questions related to it, and then we will move forward to NIM and then ternary card tricks. So basically, week one and week two. For week one, the binary representations, things we have already done. I hope you don't have any doubt in that. You just have to scan this QR. Just go to Google, normal search Google and scan this QR and join this. Uh, it will be good if a lot of you can join in this QR because in this you can write your comments and I can directly see it from this. And it is very interactive and it will always be anonymous. So I don't know whoever has wrote that question. So we don't have to be fear of that you're asking a silly question. So it will be very nice. Okay. Anyways, I just want to know how many of have watched videos of week two. According to that, I will present my ternary card trick thing. Okay, one of the guy has completely done this, almost done. It would be nice if many of you guys can join because right now there are only 5 people, and it will be nice if more people can join. At the top, there will always be a menti.com. Use this code. Just go to menti.com and write this code, and you can log into this Mentimeter. And otherwise, in most of my slides, I have a QR in the left side. You can scan it and come. Okay, none, halfway, almost done. Done. Okay. So I hope all of you have done week one at least. Let's, let's first look at the binary card trick. Okay. Uh, so in binary card trick, let's in this example we are thinking of a number from 1 to 31. So there are 32 numbers. And for 32 numbers, you have to like 1 to 31, you have to think of a number. Let's say I am thinking of a number 27. And for that 27, I there are 5 cards in which I have to say yes or no. In the sense, if yes, if my number is present in this card, no, if my number is not present in this card. So this is card one. So if I'm thinking of a number 27, so my number 27 is present in this card. So I will tick yes, this is a number. So now I will move forward to the card two. The same question they will ask whether my number 27 is this card or not. So yes, 27 is also in this card. So I will tick yes, it is in. Now, if in card 3, so you can see that 27 is not in this. So I will say no. And in this, if 27 in it, yes, 27 is here. So yes. In card 5, the last card, 27 is also present in this. So it will go for yes. Now I will just click on reveal number and your number is 27. So in this, it's a two-player game. So player one will think of a number, and player two will show these 5 cards and ask you whether whether your number is in this card, is in this card, or this card. So in that, the main thing is they have used 5 cards for numbers which are from 1 to 31. Can you, can anyone of you tell how they are deciding like what number to put in card one, what number to put in card two? Anyone? Let me show you all the cards here. Anyone can think of any strategy? How are they putting in card one is 16 numbers. Like the number which in the top left side 16 is representing card one, 8 is representing card two, 4, 2, 1. So it's a big hint if it is written 16 there, 8 there, 4 there, 2 there, 1 there. Anyone in the chat, if they know why the 16, 28, 22 numbers are there in the 16th card and these numbers are in 8th card, 4th card, 2 card, 1 card. How they are presenting these numbers? How what's the behind the scene for this binary search magic trick? Okay, anyone in the okay, people are writing here. Sorry, I haven't seen any because there was something they have written, but I can't able to see. Can you write? Once more. Why are the numbers presented in that way? Number which is getting add with other number to get that specified number. Yes, you are right. That's how we are getting the our solution. That the topmost left number is the number which we are adding in. Okay. I heard you're almost correct, but I want to just know why they are there. Like, can you explain a little? Because you're almost correct. Can anyone else want to try? If you haven't joined the Mentiquiz, you can scan this QR and write your answers here, or you can write your answers on the Zoom chat as well. Or you can simply unmute yourself in Zoom as well. Like you're almost correct in this thing that we'll go in this slide again. That, sorry, my fault. And this, the number which you are selecting, so this is the number 27. You say, just for example, our number was 27. So we can write our number 27 as 16 plus 8, which is 24, and then plus 2 plus 1. So that's why the number 27 was present on 16, 8, and then 2 and 1. Now, can you complete this? Like in 1, the numbers are 1, 3, 2, 5, plus 1. If we write the numbers in binary, then only the numbers which contain specific value will be that card. For example, card with 16 will have all the numbers with most significant bit, right? Exactly. So that's what. So the card who has the bit of 16. So in binary, if you write 0, 0, 0, 1, so whoever has the bit 1, like in the last in it, have all the numbers will be 2 till 1 to 31 will be in the 1 bit card. So whoever has the 2 bit card, so 10, whoever has the number who has 10 bit in it, all the numbers will be covered in this and this. And in another way, which it is that simply write 27, you can write it in the form of 16 plus 8 plus 2 plus 1. So it will be in the card 16, 8, 2, and 1. And that's how you construct this binary search trick magic. Okay, I hope you understood this card trick. If you have understood, okay, is there any questions regarding this binary card trick? Okay, let's do this one question. In one, all are odd numbers. Yes, that's a nice observation that in one there will be all odd numbers. In 16, all are 16 to 32. in it, correct? Because to get the 16-bit number in it, you have the numbers of 16 to 32 in it. Yeah, you're absolutely correct. Can you speak louder? Okay.
Uh, is it fine now? Like in one, the numbers are 1, 3, 5. That we have, I think, already seen. Fine. Okay. Numbers which is getting add with the number, yeah, that we have seen. Okay. So let's, if we have understood this binary card trick, let's see some questions regarding it to get the gist of it. Okay. Now I'm saying, suppose there are total 4 cards you have, and your friends are saying that their number is on card 1, card 3, and card 4. And remember, these are not the that I'm saying that topmost left number is indicating that it is 3 or 4. And just saying your card, they have like total 4 cards, and they're showing you 4 cards. So your number is in card 1, and your number is in card 3, and your number was in card 4. So can you guess what will be their secret number will be? You just have to type the number in it. Okay. One person is saying 2. Any other guesses? You can take your time in this. Okay. Some of them say 13. So in the previous example, for example, you can think of that card 1 was of 6, who has topmost left was 16. But that is a 5, total cards were 5 in that case. So in the previous case, I am showing you total 5 cards, and the topmost left card of card 1 was 16, card 2 was 8, card 3 was 4, and card 4 was, I think, 2, and card 5 was 1. So now I'm saying there are not total 5 cards, there are total 4 cards. So first see what will be the range of the cards will be. Yeah, correctly. The range of the cards are not now 1 to 32. The range of the cards will be from 1 to 16, because I am showing you only total of 4 cards. So I can at max can show you 2 to the power 4. That is 16 cards. Now the card 1 which I will show, what the topmost left value of the card can be, like how the 4 cards bits can be. So now if there are only 4 cards, so there are 4 bits of that. So first, the card 4 will be of all the same as 1. The topmost left card is 1, that all the bits who has last 1 in it has been that. The second card will be of 2, again the same, that whoever numbers have the bits 1 0. Third will be of 8, sorry, 4, whoever has 1 0 0, and another one will be now 8. So now the topmost card 1 which I'm showing has the topmost left digit is 8. And then you are saying in card 2, your card is not present there. Yeah, the binary representation will be 1011. Exactly. So now the card 1 has the topmost left side is 8, and card 2 has the topmost left card number is 4. Card 3 has the topmost left side is 2, and card 4 has the leftmost side is 1. So your card and the number your friend is saying the present on card 1, card 3, and card 4. So it is present on 8, 4, sorry, 8, 2, and 1. Okay, let's look at the written example. So the binary representation of it will be 1101. So your card was present on the first card. If card was present, so your card was present on fourth card, your card was present on third card, and your card was present on first card. So it is 1101. So it will be 2 to the power 0 plus 2 to the power 2 plus 2 to the power 3, which is 13. In a much in this example, which we have, so our this is our card 1. If we go one by one form, card 1 was 16, card 2 was 8, card 3 was 4, card 4 was 2, and card 5 was 1. So card 1, so now I'm saying that my card was present in card 1. That means it is present in not in now, because my range is now 1 to 16 and my total cards are not 5. So card 2 is my now card 1. So it is present in 8, and then it is present in card 3. So not in 4, but in 2. So 8 plus 2 is 10, and card 4. I think there is some mistake here. It will be 11 in that case. Okay, let's move on to this because I think this is the wrong example. Okay, you guys can join so I can ask some quiz type of questions in it. Okay, now if I want to do this trick for numbers for 64 cards, like 0 to 63, then how many total cards do we need in this? Yeah, that was the reason in the previous case. The order of cards was not specified. That was my fault. Yeah, so the answer was 6 because 2 to the power 6 is 64. That means you need at least 6 bits to represent your numbers in the binary card trick. So you need 6 cards for that. So, like on the first card, wherever it is 1 there, you will present that card in the 1 bit. Whoever has the card in the second bit, second last bit 1 is there, you'll present that card in the second card. And third last bit is 1, you will present that in the third last card, and that's how you will present your cards. So to make a map of numbers to these cards, you will need at least 6 bits. Okay, to clear the last uh, problem, I think there was a problem in that question and it is not well explained as well. So I was saying the card was present. Let's move to the last question. uh, Suppose there are total of 4 cards and it is present on card 1. So card 1 here presents the topmost left digit will be, okay, I can't able to actually write much this. So let's say card 1 will have topmost left digit will be 8 because for total of 4 cards you can present. So for 64 we are taking 6 cards, so that is 2 to the power 6. Now for 4 cards it will be 2 to the power 4 numbers we can present. So 2 to the power 4 cards, it will present you 16 numbers. Let me stop sharing this. So your card is present in card 1, card 3, and card 4. And there are total 4 cards. So, how many, first of all, your question is how many numbers can you present in 4 cards? It will be 2 to the power 4, that is 16. So, you can present only 16 numbers. And it will be from 1 to 16. So, generally, card 1 we present with who has topmost left, like who has the bit of 16 8 in it, because if you are presenting 16 till 16 number, so who has topmost left side, it is 8. That means the smallest number in it, smallest number I should say, smallest number is 18, sorry 8. And card 2, so it has all the numbers who has bit 1 and maybe something else, 1 0 1 1, any permutation of this, but it has the bit 1 here. Now card 2 will be of card 3 and card 4. Card 4 is 1, card 3 is 2, and card 4 is similar way. Now your card is present in card 1, card 3, and card 4. It means card 1 means 8, card 3 means it has 2, and card 4 means it is 1. That means the number should be 11. I hope this is clear now. If anybody has any doubt, you can say here. It is clear now. Yeah, that's the problem. The order was not specified. I hope this is clear now. Okay. I think this you will not have doubt in this question. So shall we move forward to the NIM game, or do you have still doubts? Any doubt in the binary tricks? If you have any doubt, you can comment that, and I'll try to resolve it because it was messy to explain binary card trick for me. Okay, shall we move forward? Are you guys clear about that card question? You can again join this using this QR. Now, yes, ma'am. Okay. So it was clear. So let's move forward to the NIM game. Okay. So let's first do NIM with just two heaps that we usually do. Just let takes 1 and 13. Can you tell which uh do you want to be the so NIM game, whoever has actually not seen NIM game, first let's explain what NIM game is. So in NIM game, it is again a two-player game. So these are stones, 11 stones. So one building has 11 stops. You can say heap or building. We usually call it a heap. So one building has 11 stones and one building has 13 stones. So you have to take, so player one will come and take some stones from only, but you can some stones from that building, but you can take only stone from only one color of the building. So you can take 5 stone from this building or 11 stones full stone from that building. How many you can take, but and then player 2 will come and take another some of the stones. So the player who wins will take the last stone from it. So whoever took the last thing will win. For example, in this case, I just took this game. Then player two come and take this many. Then player one takes this. And because I am player two and I want to win, so I will take all the four. So I take the last stone, so player two wins here. So let's define another. Just say 16 and 13. So can you tell if both the players play ideally to a strategy in this position, who will win the game? Player 1 or player 2? I hope you are clear with the right. Can you tell who is going to win? Any so player 1 has 16 blocks, other has 13 blocks. So and if not, what should be your strategy should be of player 1 to win or for player 2 to win? So do you want to be player 1 or player 2? The question is this in this particular scenario. If you want to win. When the piles are unequal, player one will win. When the players when played ideally. Right. Player one, okay. One has set player two, but okay, we will show why player two will not win. Player one will win to win. We just have to make the piles equal in every turn. Exactly. So why player one will win and why not player two is let's because for the same reason which you have said, that player one just wants to make every time the piles equal. So in player one, let's player will come and just remove these three stones from here. Now player two have to come and make some of the stones remove. You can't able to skip. So player two will come and remove this 8. And then player one will come again and just remove these 5 stones again. So player 1 will always make the mirror strategy. So whatever you will do, player 1 will just repeat. So player 2 will take 2 and player 1 will come and just do the same what you are doing. And maybe player 2 is frustrated and goes all over and take all the 6. Then player 1 will just take all the 6. Now I hope you are convinced that if the piles are unequal, then player 1 will win. Is there any doubt in this? That why player 1 is winning? I hope this is clear. Let's try to do some questions regarding it. If you are not joined, if you are not joined, then please join using this QR, which is given because we will ask some 2 questions regarding this. Okay, let's just ask this question. In the two heap game, the same game which we were seeing earlier, why does this making the heap equal? Like these are stones, so there are one building has n stones and one building has 2 stones. Why this always works? Like why do you always want it to be the same? Yeah. So it is not why the mirror strategy always work. So I don't know if you know what is Zor sum is. So Zor sum is when you add in the two binary sum, if you are adding 1 plus 1, then it will become 0. And Zor sum of 0 and 1 is 1. And 0 and 0 Zor sum is 0. So if you Zor sum both the stones, so n plus basically n Zor sum n will be 0. Because if you write n in the binary and if you write n in another binary, it will always be 0. In practice, you can write, for example, write 3 in binary. So in binary, 3 will be written as 1 1. So if you're making two heaps to be 3 3, so if you add those, 3 is 1 1, another 3 is 1 1, you are sorting them 1 1 1 1. So Zor 1 is 0 and 1 Zor 1 is 0 again. So it will become 0 0. So this binary Zor sum of these two equal numbers will be 0. So binary Zor sum of every time equal numbers are 0. So that's why this strategy even works. That's how why you can mirror those strategies. Now let's move and look at multiple Zor sums. Okay, this I think will be I should define. Let's move forward to some 3 heaps and not 2. And okay, I think 5, 7. Let's look at smaller numbers. 9. Let's go to this. Now, what do you think? This is the same game, but there are 3 heaps. Now, what do you think? Player 1 will win or player 2 will win in this case? The same thing we will have to do. Player 1 will come and take some stones. Player 2 will come and take some stones. So, now what do you think? Who will win? You can write in the Mentimeter chat. I'm also seeing if you have any answers. Hmm. People are saying player 2, and one guy is saying player 1 will win. Player 2, player 1. May I know why we have changed the meeting format from Zoom to YouTube, ma'am? No, we are also meeting in Zoom. There is a link provided to you, I think, for Zoom link. So there is a Zoom link as well. This is not necessary to be in the YouTube. Player 2. Okay, people are saying player 2 a lot. Okay. Can you also explain why player 2 should win? If you are writing anytime player 1 or player 2, that will be very nice. Okay. Now let's look at this and let's look why player 2 should win or why player 1 should win. And this is like for 9, 8, and 5. So we are having three heats. One is 9, 8, and 5. So let's look at this. So whoever has set player 2 is wrong, and whoever set player 1 is actually correct. Because in player 1 and player 2, if you have watched the lectures, then you will get it instantly. Did you have to balance out all the binary sums? So if you XOR now these values, so these blocks are representing, so these are representing the bits which has 1 in it. These are the bits which I have 2 in it. This is 2 square, this is 2 cube, and this is 2 to the power 4. Now, so 9 you can represent it as 1 0 0 1. 8 you can represent it as 1 0 0 0. 5 you can represent as 1 0 1. Now if you XOR sum these in the binary format, 1 plus 1 will be 0. This is 0. This is just 1, and this is 0. So it will be 0 1 0 0. So XOR sum of these binary sum is not 1, 0, sorry. So to make it 0, we have to balance this one as well. So to balance it, we have to basically make all these into the green blocks. By green blocks, I mean I have to make it even number of pairs. So these are just 4. If player 1 comes and just remove these 4, now player 2, whatever player 2 will make, player 1 will again make it balanced. So player 1 can come and make it balance. Player 2, sorry, at come and take this. Now player 1 have to make it balance it again. So for player 2 to make it balance, it can create two fours. So it will just make create 4 less and remove this one. And player 2 can become angry and remove all those four. Then better for player 1. Player 1. And again, this is a simple task. Player 2 comes and player 1 just take once. Then that's how the player 1 will win. So if we are zoring binary sum, you have to zor it term by term in it. Okay. I hope this is clear. If you have any doubts, you can ask. Okay. The heaps are 100, 100, which has a non-zero sum. Exactly. So player 1 should win. Right. This is the correct explanation. So just have for every time you just add them and check whether their Zor sum are 0 or not. If their Zor sum are 0, then player 2 will win. If player Zor sum is not 0, then player 1 can make it Zor 0 and player 1 can win. So this is the simple thing you can check every time. Okay, let's move forward and let's. Okay, uh, okay, this is, I think we can skip this question. I think. Okay, now let's look at four hips and I want you to try in it. Can you tell if now there are four hips, one has size 10, another has size 16, another has size 9, and the last one has size 21. Can you tell now this position is winning for player 1 or losing? So you know the strategy of source sum now. You know the strategy of just writing it in the form that this should be balanced. So can you now tell? Just basically write it in the form of binary and try to Zor sum it. Okay, one is saying winning, one is saying losing, one is saying 10, 21. I don't know why they are saying 10, 21. Just I want winning or losing, winning position, winning, losing. And if you guys have not joined this Mentimeter, again, you can just scan this and join. Okay. Only 8 of you have answered. It will be better if more people answer. I don't know why you are saying 21. Are you saying that you have to take blocks from 21, from 16 or 10? Yeah, that will be nice if you can also tell that where you should take your blocks also from which stone you should, from which building you should take your stones from which heap basically. And meanwhile, if you have any comments or if you have any doubts, you can ask also. Okay, let's wait for 1 more minute because it's not so easy. Okay. Now let's see who's going to win this. The question was about there are four heaps: 10, 16, 9, 21. So there is blocks. This have 10, 10. Similarly, it has, so it will be 16, 6, 7, 8, 9, and this will be of 21. So on. Also so on. So these are your four heaps. Now you want to check whether it is winning for player 1 or it is winning for player 2. Now to check it, simple strategy is to check their Zor sum. So 10 you can write as 8 plus 2, which is 2 cube plus 2. So you can write it in the form of 0, 1, 0, 1. In the binary. The 0, 0. It is 1 to the power 1 into 2 to the power 3, 0 into 2 to the power square plus 0 into 2 plus 1 into 2 plus 0 into 2 to the power 0. So if you look, it will be 1, 0, 1, 0. 16 you can write directly as 2 to the power 4. So it is 1 to the power 2, 0, 2 to the power 3 plus 0 into 2 to the power square plus 0 into 2 plus 0 into 2 to the power 0. It is 1, 0, 0, 0, 0. So it is 1, 0, 0, 0, 0. 9 you can write as 2 to the power 3 plus 1. So it is 1 into 2 to the power 3, which is actually 8, plus 0 into 2 to the power square plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. It is 1, 0, 0, 1. So it is 1, 0, 0, 1. Now 21 you can write as 16 plus 5, which is 16 plus 4 plus 1, which is 2 to the power 4 plus 2 square plus 1. So 1 into 2 to the power 4 plus 0 into 2 to the power 3 plus 1 into 2 to the power square plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. So it is 1, 0, 1, 0, 1. So it is 1, 0, 1, 0, 1. Now, if you Zor sum these four numbers, so if you Zor sum these two numbers first, because these are of equal size, and Zor sums these two numbers, so these two numbers will give you, because Zor sum is commutative, so basically you can interchange them. So if you Zor sum them, so 1 Zor sum 1 is 0, 0 Zor sum 0 is 0, 1 Zor sum 0 is 1, 0 Zor sum 1 is 1. So it will be 0, 0, 1, 1. Now if you look at these Zor sums, 0 Zor sum 1 is 1, 0 Zor sum 0 is 0, 0 Zor sum 1 is 1, 0 Zor sum 0 is 0, 1 Zor sum 1 is 0. Now if you both add these two, you can first correct their size. It is 1, 1, Zor sum 1, 0, 1. You can write 0. So 1 and 1 XOR sum is 0. 1 and XOR 1 0 is 0. Sorry, my bad, it is 1. And 0 XOR sum 1 is 1, which is non-zero. So player 1 should win. I hope this is clear to you all. If you have any doubt, you can ask. And in a strategical way, if you can look at this, let's define in this way also. I think I have no 4 heaps. One is 10, another is 16, one was 9, and one was 21. So if you look at this, you can look at that. There are two reds which are not in a balanced form. So it should be all should be in the green form. So that's why player one should win. Okay. Is this clear? Why it is a winning position for player one? If you have any doubts, you can ask. For the position, then we take out 4 from the 21. Okay, let's look at this. Okay. In this, you are saying you take 4 out of 21, but if you take 4 out of 21, then the 16 will become imbalance. So it will not be a good strategy to take 4 from 21. I don't think this will work. Okay, let me ask this. What do you think we should remove from how player 1 should win, and how with how many blocks, and from which building, that how many stones should the player 1 should remove so that this become balanced? Okay, you can answer in the Mentimeter. I will see that. And try to think which block you should take out so that 4 blocks from 21 will not work here. Okay, I think some of you may have got this. Take 2 from the heap 21. No, we actually can't able to touch 21 because then the 16 will become distorted. So 21 we can't able to take. No, we can't take 2. In 4, 2 should be removed so all will be even. Yeah, but where from 4 to I don't understand. So if you remove 22 from 21, so the number will become 21 now. So it will have different binary representation there. So in this case, if you take 2 from it, oh sorry, 19. Yeah, so this will work. 2 will work from this because you can make this into 2. So 2 will work, but 4 will not work because this 2 will become left out. If you remove 2, this become 2 and now everything becomes balanced. Okay. Okay. So this is all about NIM and binary card trick. In the next class, we will try to do ternary card trick. So if you have any doubts and questions, and try this, use interactives dot Neeldhara, and you can try in it. So Neeldhara ma'am is teaching you, and you can try in her website and these meme games. So try and what strategy you should follow. If you have any doubts in it, you can ask for any class from any classes for week 1 and week 2 we will cover next time. Week 2 in which we have covered all the NIM questions. For ternary we will try for the next class. And it is better I think if I do it from my from writing in the notes because in this way we can't able to complete all the questions. So if you have any suggestions or anything, you can ask and say. Is the previous example clear to you all? So taking 2 he will working from 21. In 4 oh I you mean 21 in 4. Okay. The fourth building. Okay. Yeah, that is also correct. Sorry. I didn't understand it earlier. Okay. Yeah, my bad. I thought 16 will become imbalance. Thanks for clearing it out. Okay. If there are no questions, then this is the end for today's class, and we will meet next Saturday, same timings. Yeah. We will try to do ternary magic trick in the last. Yeah. Thanks for joining.